Welcome, everyone, to Mark Voids a Warranty. I'm Mark, and I'm here to break something today. And today, we're getting in the mood for the holidays with children's toys. So, I've got this little Conti- tech, I don't know. I've got a little light up RC car complete with remote controlled wristband, all Dick Tracy style, right? Isn't that cool? I mean, it's probably meant for a child's hand, a child's wrist, but we've got that. And check this thing out. It lights up. How fun is that? It's got these little RGB LEDs. It spins around. Let's make it spin. What up? I guess do it over here. Go forward and backwards. There we go. So how does it turn? I don't know that it does. I don't know what all those buttons do. But as far as fun goes, it's fun. So let's take it and take a look and see what we have. First things, the transmitter, and we can probably get to an overhead view now. So our transmitter is powered by a couple of AA batteries. It's relatively low power, and it's 2.4 gigahertz in the ISM band. It's pretty limited. I had a little RF power meter for my amateur radio that's supposed to work in that range, and it didn't even detect it. So I don't know if that's the meter or this, or I don't know. We'll see. So it's reasonably well built so far. We've got 4 screws holding everything together. You can actually screw the battery compartment on, which is good if you're a parent and you've got little kids that throw things around. I mean, they don't even have to intentionally drop something for like the back to fall off a remote. I wish they'd do that sometimes. Okay, and inside, it appears that we've got a single layer PCB. Manufacturing date looks like a part number BY2106SO2TX, so the transmitter. All right. And then a variety. I've actually never, actually, I don't know why they would. Okay, so one of the things I've seen different sized tactile switches, but I've never seen 2 sizes of tactile switch used on the same design. They have about the same height, the same vertical profile. So I really don't know why that is. That's interesting. I wonder if that was a mistake or what. I don't know. So on the front side, we've got your typical spring contact connectors. And then on the back side, I'm going to have to cut them. They're soldered too well. That's good. We've got a little single IC transmitter. There's really not much to this. I mean, we'll have to pull out the microscope in a minute. There's 1, 2, 3, 4. Looks like there's 5 0402s and a couple 30603 parts, a crystal right on the back side, and then the IC and the switches. And that's it. So, I mean, as far as if you have to come up with a tiny little remote control, that's not bad. That's pretty easy peasy, and it's running off a 3-volt just fine. All right, so back to this guy. So the 2 front tires are connected to a single axle. The back tires are connected to a single axle. There's no differential drive. So back to my question of how does this thing turn? I don't know that it does. I think it just flips around and goes nuts. I know what you're saying, Mark. You should really turn off the power before you take things apart. Yes, I really should. I should really take the battery out, but I don't know. I like living dangerously. Let's see what we can do here. And just see the two screws. Okay. Also screwed on, and we've got a little LiPo battery. This is a little 3.7 volt that's been retrofitted into what would otherwise be a 4.5 volt compartment. So that's kind of interesting. I don't know why they did that, but obviously this thing's gone through a redesign. You know, it could be that they weren't able to get their springs or something. I don't know. Seems to me that the cost of a LiPo would be more expensive than those spring contacts, but I could be wrong. Okay. We are in the middle of this thing. Ooh, interesting, interesting. I'm going to put that battery back in. I want to look at those LEDs. We might even pull out the oscilloscope today. These are 2-wire LEDs, but they're changing colors. So these signal, okay, so they're going out of sync right now. So the reason that I wanted to look at this was, are these things getting powered and oh, I can't turn off the overhead lights, can I? I was wondering if these things are getting powered and signal on the same line, which is possible, but it doesn't look like it. They're getting way out of sync now. So these things are just little LEDs that are programmed to blink semi-randomly. That's adorable. And I know I'm swamping the sensor on the camera. Otherwise, you guys would be able to see all the different color patterns. That's really neat. Your little right angle LEDs. Probably be easier if I let the light shine on something. And then they've got these clever little patterns that they do. One thing that's interesting too is that there's no current limiting resistor, or at least on the wire aspects of things. Okay. So those things are free. I don't know what those are doing, but maybe they'll come in use in a future project. I don't think I'm going to get rid of those. I like them. Whoops. All right. Yeah, MTJ and Anubhav, I think we need to void a LED. We're going to get these things under the scopes in a little bit and see if we can't see an ASIC in there with them. I don't know. Maybe we will. Maybe we won't. I have seen flashy LEDs. I mean, going back into the earliest I probably remember them is the 90s. You could get an LED, hook it up to a battery, and it would just go there and blink forever. But that was a single color. I haven't seen these color changing pattern ones. So that they're out of sync doesn't excite me nearly as much as if they were in sync, because if they were in sync, that would mean that the LEDs are getting a signal as well. All right, so on our receiver board, it looks like we're going to have to do a little bit of desoldering. Our receiver board, we've got two ICs. One of them, I assume, is going to be controlling the current to the motors, and then the other one is the receiver for the RF section. But man, these boards don't get any simpler, do they? How neat. Okay, let's see if there's anything else we can see before we start getting into the IC analysis. And in fact, once I get this apart, I do think I'm going to pull out the oscilloscope and see if there isn't anything we can notice on those signal lines from those LEDs. Come on. There we go. Lucky I didn't put that screwdriver through my hand. That wasn't too safe there, Hughes. There we go. One axle with a 3mm rod. Free. So we've got a 3-volt motor with, looks like it just spins around at a pretty good clip. I don't know what that's good for, but troublemaking will cause some trouble with it. I don't know what yet, but something. And then we've got another drive axle. Come on. Come on. Need an angle grinder. My goodness. Okay. I think that one wants to stay for now. I can feel some slop in them. I guess not. Okay. Well, let's do this. Let's get rid of this stuff and move into the oscilloscope portion of today's events. That'll be fun. Go ahead and let that start powering on. All right. Now, another issue that we're going to have, since I had to cut those battery connectors off, is this thing's going to need a little bit of power. The transmitter, anyway. So I am going to hook that up to my handy dandy Textronics EDU 36311A power supply that I won in the Keysight Dream Benchtop something. I don't know. I won it in some contest that Keysight put on. They sent me 4 bits of test equipment. It's very nice of them. Okay, channel 2. I need 3 volts. One, 2, 3. No, I just put 300. Haha, that's going to make it mad. Let's try that again. 3. Enter. There we go. All right. This bad boy is now live. I don't have any way to show you the power supply, but I basically just turned it on to 3 volts and turned it on. Next up, we need scope probes. I thought they were right here. Silly me, silly me. I must have moved them. Give me 1 sec here. If not, I'll grab a couple new ones. They should have been right there. Boy, I tell you, I'm a troublemaker. Aren't I? Aren't I? There they are. Make sure I have them for the right scope. I do not. That's okay. They'll work. The scope that I can put on camera is a little different than the scope that these probes are designed for, but let's just see what happens all the same. And I kind of am interested first in what kind of signal we get out of this. So let's see. We've got power. Keep those separated. I've got it set to 3 volts. I've got it set to on. That's done. I've got an oscilloscope. And let's see. I'm getting a lot of noise off that scope. So I am going to see if I can't figure out where to attach a ground and see if that doesn't improve things. Only for the simple fact I'm seeing more noise from my lighting setup than I am from that. And nothing. I can't show you anything. It's showing a straight line. All I'm seeing is 60 hertz hum, which I can show you. It's all RF noise though. So 1, 2, 3, 4, 5. Nothing. It's not even showing up now. Okay. Well, I tell you, I'm not doing too well. Let's see if there's anything else we can see. If we get rid of that RF, let's see if any. Nope. Okay, so a couple issues at play. One is that I don't have the probes for this scope, and this is a scope that kind of likes having its own custom probes. Ha ha ha. Other issue is I've got all this LED lighting, and well, I guess 3 issues. The lighting is absolutely swamping the signal that's coming out of this tiny little board. And then the third issue, which I haven't quite troubleshot yet, is for some reason the scope's not coming out onto the display. So let's give that a break. Maybe we'll circle back to it. But for now, let's see what we can see going on these boards on our microscope view. So this is our first board. It's a transmitter. Again, it's a single layer board. And this is the IC, unmarked, which is Lamesville. But I'm sure if we needed one, we could copy it. It looks like there is we've got a little inductive matching circuit right there, some unpopulated pads. It does have an inductor going there, so that must be the antenna out. Little decoupling cap. As we move down. Not the cleanest solder joints I've ever seen, but that kind of happens when you use an unplated board. It sits there and it absorbs contaminants. Looks like that they've got a little decoupling capacitor there. Pull-up resistor. Another couple pull-up resistors or pull-down resistors. And then all of these guys, I mean, that's all that's on the board. Everything else is switches. So they have the switches running each to their respective part. Looks like they missed a pad there. Whoops. That looks like a mistake because everything else has a pad. That's the only one like that on this field. So they've got a little, almost like a scan matrix, not really though. Some of these things though, if you look, you can start seeing where quality control just didn't quite work out for them. You know, here's another one where you've got missing pads. There's really not a whole lot of good reasons to do that. You can also see how offset the anti-pad is from the hole, right? It's way off. That's significant. I don't have anything to measure that with, but that's got to be off by 30, 40 mils. That's a big boo-boo. There's another pad they missed. Okay, so they missed pads all over the place. But why? Why not just put a pad there? I don't get it. Well, that's probably about all we're going to see. You can kind of make out that they did use those two different size key switches. Not key switches, tactile switches. And then that's all there is on this board. And the antenna, which I'm not able to do anything with at the moment. Next board, let's see what we have. And if not, we'll move on to our next project. Okay, so with some better lighting, we could make out this IC. It looks like it's SA8302 on the first line and 132 for the next top level marking. Solder joints aren't the best and aren't the worst I've ever seen. Looks like they're a little light on the solder. There might be some potting on top. See if I can get you a little better view. I mean, you wouldn't expect a lot from a product like this, but that's kind of on the nice side of what you might expect. Contamination all over the board. Really no effort made to clean this thing after they did the assembly. Looks like we've got a little SOT 23.3 package, an unmarked IC. I don't see anything resembling marking on that, so that must be the other RF1. Must have gotten them from the same supplier. Yeah, so we've got another inductor here coming off the antenna in. Some capacitors for a little tuning circuit. So we have one transistor. I could believe that runs one of the motors, but we've got two motors. So are they running it straight off the IC? Got an electrolytic cap as a reservoir cap. We've got a shrink wrapped crystal antenna. Ugly solder ball right there. Another solder ball just floating off in space. So not the best QC, but again, for products in this particular price range, I have certainly seen worse. It's not that bad. Probably the only thing I would recommend is um, solder those extra pads. Give it that much more mechanical strength. It doesn't cost you any different. Yep. Unmarked ICs are better than ICs without data sheet. Yeah, I'd say they're about the same. It's don't know what it is, don't know what you're dealing with. So interesting. Okay, well, without an oscilloscope, and I don't want to have you guys wait while I get that working, there's not much more I can do with that particular product. But that's okay. It's not the only RF device that I have today. I knew you guys would want more. So what I have for you is this little guy and this little guy. This is a RCA RF receiver and camera transmitter. I used this back when I was teaching to give kids a different perspective of what things would look like. You know, if you're spinning something around for talking about centripetal motion, you know, you would put this on and just give them another perspective. It worked okay. It was like $30. Little power supply, receiver box, and transmitter box. So let's see what these guys have to show us, huh? Okay. Oh, LED in the microscope. Yes, I'm sorry. Before I do that, thank you so much, MTJ. I'd completely forgotten. LED in the microscope. Let's see. If there's anything to be seen. Yep, I can see it. I don't know if you can or not. I might have to zoom in. Let me switch over to that view. So there's some glare issues. But here you can see the silicon die right in the middle. There's 1, 2, 3, 4, 5 bonding wires that go out to somewhere. So we're probably looking at the part that was doped to give it the light emitting properties. Oh man, I don't know if I can do any better than that. It seems like any direction I go, there's glare. And then on the bottom side, I wonder if we can see the epoxy there for the IC that's doing the drive circuitry. No, we've got it sitting right on an anode and cathode. So that whole IC. So why do we have so many wires coming out? So you'd expect to see the anode and cathode of any IC would look like that, or any LED would look like that. Okay, I know what I was looking at wrong. So that thing in the middle, that is the ASIC, the application-specific integrated circuit. And I didn't see these at first. I don't know if you can see them at all. Those are the light-emitting diode aspects of it. One's marked T. I can't see markings on any others. And getting them visible to you is, man, that's going to be a trick. But you can kind of make them out. They're little 2 connector devices. Those are the those are going to be the colored ones. So there are 1, 2, 3, 4 wires going out doing that. You can kind of see 1 there, 2 there, 3. You can kind of make out the marking T if you use your imagination. So that is the driver IC. And I bet if I could hold on to this and we could zoom in, I bet you could actually see some of the gates, but I don't know if I can even zoom in that much. I think I'm towards the top of my... Yeah, you can start to make them out. So you can start seeing the doping there. But it's really, you got to use your imagination. So anyways, thanks for reminding me about that, MTJ. I'd forgotten. I got flummoxed. Where is my... There we go. Okay. Back to this guy. I mean, there's all sorts of little cameras and modules that you can get now, but this was really useful in the, when I had this, and I forget when I had this, 2000s or so, just to help people see other perspectives. Especially when you're teaching physics. On a side note, before we came on today, when I loaded up YouTube, it looked like Veritasium had some content on, misconceptions about where energy is in a circuit. And it looks like he's talking about wires and fields and things. So I'm going to go watch that right after. He's a physicist. So that might be pretty good content. We might share that in our course. Okay. There's that. And let's see what we can see in the... All right, we see Parallel Logic says it looks like he was talking about impedance. Ooh, even better, all the better. That's one of those things where we've got to do a better job of teaching engineers how the world works. Because as years pass, our stuff just keeps shrinking smaller and smaller and smaller, and the edge rates get faster and faster and faster. And some of the things that you got away with in the past, you're just not going to get away with anymore. Okay, so we've got a lot of boards here, and man, they are small. So let's see what it is that we can see. First one, we've got the receiver. Pretty common technique you'll see are putting the RF radiating parts of a circuit, or the RF sensitive parts that even if they don't radiate, maybe they're susceptible, but you put them inside a Faraday cage, a metal enclosure. One of the issues that I notice is it looks like we've got a little bit of corrosion there, but that happens. Could be that they left some flux on. Could be this thing. Who knows what happened in the intervening years since when I purchased it and when I stored it. Okay. So we've got internals. It looks like this is a module and it solders through a little through-hole header. Yeah, it is. It sits higher than the rest. that unplugged. I'm going to ignore this. This is a little rheostat that adjusts the receiving frequency. There's some sort of a VCO that they're using for frequency tuning or something. And then I'd like to get this out, and then we'll look at it under the scope or microscope, and then we'll go from there. I said I forget exactly, because I had a couple of these because they weren't that durable. Well, you know how I am. I'm kind of a little hammer happy. So I don't know exactly when this one was manufactured. Here is the receiver board. What appears to be LDO for power regulation. You know, you've got the RCA out, audio and video. Little unpopulated SOIC. Those are interesting, little planar inductors. We'll look at this a little closer under the microscope. Tantalum cap missing. I guess they decided they didn't need that one. And it looks like there's another something hiding under here. I don't know how easy that'll be to get to. And then for the transmitter board, so we've got a camera module with microphone and 3-wire connection. I bet you that is just a serial data bus. Surprising that it could transfer the information that quickly. And then this is an RF board, some amount of selectability. I don't remember ever adjusting those, but maybe I did and I forgot. So interesting. Let's see what we can see, yeah? Okay, so we had a question, is the mic going straight into the black chip? And I don't know. We're going to find out. Going to have to zoom back out there. Okay, that should be hopefully in zoom for you. So we've got an epoxy encapsulated, I don't know if that's, I can't see that very well. I don't know if that's a CMOS or what driver, but you can see the little wire bond wires coming off of that. And then those connect out, and this goes to a little quad flat pack, 1, 2, 3, 4, 5, 6, 7, 8, 40 pin package. After that, it looks like we've got a relatively standard 2-layer PCB. Backside of that microphone, we've got some resistors, what appear to be some capacitors, a crystal, a couple of transistors. I don't see anything there that makes me think that that thing is that there's an op amp. I don't know if those transistors are powering something, or if, let's see, looks like this goes way over here to the right. Okay, it looks like that transistor is connected to that microphone. So I think that might be your amplification. Just a very simple semi-linear amplifier. And it could be that I'm wrong about it being serial. That would be pretty slow profile, pretty slow. So you've got power coming in, you've got ground, and then maybe you've got an audio and video RF signal coming out. That would make a little more sense to me than there being a serial connection. Boy, would an oscilloscope be great right now, Hughes, I tell you. Always doing things the hard way, though, aren't I? All right, now on this back side, you've got an IC, just a little 4 SOIC, some questionable soldering. Yeah, I don't know who did that, but I can tell you my buddy Sebastian wouldn't be happy. The board itself looks pretty clean. I don't see a whole lot of debris on it. And you can actually, if you make out in the reflections there, you can actually see the fiberglass weave pattern. Always kind of interesting. On our back side, we've got the top side markings 6701, A214, AN023. But which one of these is doing the transmitting, which one of these is doing the video processing, I have no idea. You can see some interesting things. So they did do copper pores all over the place here. And these vias, the ones that seemingly go to nowhere, go to interior layers that I can start to make out on the edge of these. But I don't know if you can, because the focus of that camera is a little different than the focus of my eyepiece. So just a regular old board. I mean, probably pretty advanced for its time. They just did what they could to get all those little jelly bean parts connected. Just all support circuitry. Interesting, interesting. Little surface mount selector switches. So, all right. Well, let's see what we have with this. So here is our receiver block. And I was just going to look around. I mean, there were some interesting things here. For example, let me get a pointer. These planar inductors. So if you have the board space and you need a relatively low value inductor, you can just build them right in. I don't see that too often anymore. But this is an old school analog circuit, right? Everything seems relatively straightforward. They were able to route this without too many crossovers. As we get in further into this RF section near this metal block, which they went ahead and shielded separately, you can see where they've gone to some pretty extraordinary lengths to do some things. I don't want to guess what those things are, because I'm going to guess wrong. But if you know, let me know. So it looks like we've got, I mean, it'd be great if I knew what these ICs were, but we've got an AT2860, HB12430. I'm sure we could reference that. Is that a tantalum? What's that big fat guy do? Bunch of surface mount stuff. This was probably state of the art back in the day. Things have really changed quite a bit since then. You can see where they necked down some traces so that they'd have better connectivity for their via pads. It's probably, I mean, I'd have to pull that up to look, but it could just be a keyhole. Let's see if I can see. Yeah, so they wanted to keyhole those a little bit just in case the drill wandered, that they wouldn't get breakout. I mean, processes have changed quite a bit now versus then. Now we've got machine vision aided drilling processes. We can put those holes right in the middle of a pad. But as you saw with that car, we didn't always have that stuff. So you would do things like this. This is a better example, easier to see, where you would have the trace grow in size for a short segment so that if the drill wandered to the right, you would still hopefully have enough copper for you would still have enough copper so that you don't have breakout. Okay, Parallel Logic says the A&O doesn't come up with any good hits when I search for it. Yeah, so sometimes those top side markings are product IDs, which makes reverse engineering great. Sometimes they're lot numbers and date codes. So there are books that you can get. I used to have one that will help you cross-reference a lot of that stuff from different manufacturers, but you spend a lot of time researching to figure out what that stuff is. So you have to really want to know. And sometimes you just have to get lucky. It's better to be lucky than good finding what these old things are. Okay. I wonder if I can get in. I don't know if I can get into that. I don't think I can. All right. Is there anything else viewers out there in TV land would like to see? I'd be happy to show you or walk you through it or hit something with a hammer. I like doing that too. Interesting. I mean, these parts look, the only one I don't recognize or I when I say don't recognize, I have literally never seen a part like this before. And I have no idea what it is. Where did it go? It's this one right here. Black and white. Black on one half, white on another. No idea what that does. Everything else, I mean, capacitors are unmarked typically. Resistors are marked. So we've got, our 101, 471, 473s, another one of those white black things. I don't know any two SMD parts that are colored like that. It could be that we don't use them anymore. It could be I just have never seen it. There's plenty of stuff I've never seen before. And then when we do when you look around, when they did have to use vias, it looks like they used multiple vias wherever they could. It's something I always like doing, is it just in case. Bringing the via out to the side is also a manufacturing trick if you don't have teardrop capability, right? So if this thing goes out in any direction, it's not going to cause that connection to fail because there's going to be extra copper in every direction. So if you don't center your via wires, your nets, it's actually, in my opinion, a pretty good thing. And that's about it. Interesting. We'll talk about fun in RF land today. All right. Well, that's pretty much it for Mark Voids of Warranty on this beautiful Friday. We're going to be back in 2 weeks, so December 3rd, with our next Mark Voids of Warranty. And what will I void? Who knows? The world is my oyster. And I'm sad I didn't really get to smack anything with a hammer today. But fear not, I will. The day is young. All right, everyone. It's been fun. Thank you for everyone who joined me today. Parallel Logic and MTJ and Jesse and Anubhav and Parallel Logic. I really appreciate it. We're still doing Teach Me PCB. If you guys are involved in that, I'll keep up with you next coming week. We've got our own board layouts to do. That's going to be exciting. You guys have never done a board layout before. You're going to learn a lot. Hopefully a few things watching Mark Voids of Warranty, but a lot of times we do this for fun. So thanks everyone. And thank you for our sponsor, Advanced Assembly, who makes this all happen. Take care. Bye.